In this video, we will look at how to use the ALEKS graphing calculator to find local extrema of a polynomial function and to find zeros of a polynomial function. This problem says the polynomial function h is defined by h of x equals negative 3x cubed plus 9x squared minus 3x minus 4. And we need to use the ALEKS graphing calculator to find all the points x h of x, so that's an xy ordered pair, where there's a local maximum. So first I'll open up the ALEKS calculator by clicking over here. And I will go to my y equals. In my y equals, I want to type in my function, negative 3x cubed plus 9x squared minus 3x minus 4. Now to get the exponent in there, I'm just using the shift 6 on my keyboard and then my right arrow on my keyboard to get out of the exponent mode. Once I have that, I want to go to the graph and make sure I have a good window. I can see the local maximum. It looks like there's only one local maximum for this problem. Then I go to this Extrema button right here. I click on Extrema, and in this problem, I'm only looking for the maximum. And so I want to go ahead and pull my right bound so that it's to the right of that maximum, and pull my left bound so that it's to the left of the maximum, but not to the left of the minimum. It will mess it up if my left bound is too far away from that maximum. So I might go to a left bound of +1, and then do the right bound of, we'll just go ahead and do 2.4. And then just check and see if you are to the left of the maximum and to the right of the maximum, but don't include any other extrema between those bounds. I click on Find Extrema, and it actually gives me the point up here. It will also give you the edge, like the minimum on that boundary, on that x interval, but you can ignore that. All we care about is that highest point, that local maximum. So over here, I'm going to go ahead and put 1.81. It says round to the nearest 100, so I'll do 2 decimal points. And 2.27. 2.27. All right, so that's how to find a local extrema. If I was doing the minimum on the ALEKS calculator, pull this back up, go to my graph. I guess it cleared it out, but if I was doing the minimum on that ALEKS calculator, I would do the same steps, but I would pull my left bound and right bound so that it's closing around the minimum instead of the maximum. And if there was more than one extrema, like more than one maximum or more than one minimum, I would have to do that process for each one individually. Okay, now let's look at how to find zeros using the ALEKS graphing calculator. This gives us the function 3x to the 4th plus 7x cubed minus 5x squared minus 12x plus 3. And we're asked to find all the zeros of the polynomial function. I'm going to pull up my ALEKS calculator here, go to my y equals, and I have to type that in. I'll do 3x and then the shift number 6 key to get to the exponent. My right arrow to get out of the exponent. So I have 3x to the 4th plus 7x cubed minus 5x squared minus 12x plus 3. And go to the graph to make sure you have a good window. Okay, we have a window where we can see all of the x-intercepts, which is what we're looking for. Zeros are the same as x-intercepts. And they say if there's more than one answer, separate them with commas. So I'm going to go to this 0 button here. On the 0, for each x-intercept, I'm going to have to drag the left bound and right bound so that there's exactly one x-intercept between the left and right bound. And I'll click on find 0. All right, so this is a good example of scientific notation. The y that they're giving me is negative 7.27329,308 e negative 12. That e negative 12 means times 10 to the negative 12th power. So that means that it's 0.0000, 11 zeros before I get to the 727. The scientific notation, when you have such a large negative exponent, in this case the negative 12, that number is essentially 0, which is what we wanted in this case, because we're looking for the zeros of the function. So all I care about here is the x value of the x-intercept. And they say round to the nearest hundredth, so I'm going to put negative 2.13. Now I see that there's more, so I'm just going to go ahead and put my comma there. I will go ahead and go back to 0. I'm going to find the next one over. So I go to the left and to the right of it. So notice I'm doing the next one over, the next place it crosses the x-axis. I hit find 0 and I get x equals negative 1.65. Go back to 0. And I'm going to do the next one. So notice left bound and right bound only encompass one of the places where the graph crosses the x-axis. You have to do them one at a time. On this one, I get x equals 0.24. Make sure you're rounding correctly. And then since it crosses the x-axis again, I have to do 0 again. Drag my right bound over. It's not wanting to let me grab it. And I'm not sure why it's not letting me grab it. Okay, instead of trying to drag it, I'm just going to change my right bound here in this button. I'm going to change it to 1.5. There we go. And then I'll click find 0. And I'll go ahead and put in 1.21. And we got them. We got them all. Notice we had to do each one individually with a left bound and right bound. And if it doesn't let you drag the bounds, you can type in a button or a number. And then just list all of them here. So zeros are the same as x-intercepts, meaning where the graph crosses the x-axis. So that's how to use the ALEKS calculator to find zeros. And we saw how to find the Extrema using the ALEKS calculator.